Morning. Today we discuss about frequent pattern growth algorithm in data mining. The disadvantage of a priori algorithm is it generates a huge number of candidate sets and we need to repeatedly scan the database to find the patterns. So to avoid this, we go for FP growth algorithm. In FP growth algorithm, it is not necessary to find the candidate key and only the frequent item set we can generate. So the frequent pattern growth, FP growth, is a data mining algorithm used to find a frequent item set pattern in a transaction database without generating too many candidate sets. So frequency pattern algorithm example. We'll discuss one example for frequency pattern algorithm. Consider the number of transactions are 5 in the database. Transaction ID T1, T2, T3, T4, T5. Each transactions there are a number of item sets EKMNOY. These are the item sets for T1. For transaction T2, DEKNOY and T3, T4, T5, so on. So we need to list all the items separately and write the frequency pattern. So what is the frequency pattern of this is, here we have to take items, list all items. The items are A, C, D, E, I, K, M, N, O, U, Y. First, we have to write all the items in this order E, K, M, N, O, Y, and we have to arrange it in ascending order, which means here we have items set as alphabets, so we have arranged in ascending order. So A to Y. So how many times A appearing? The item A appearing one time in the transactions, in entire transactions, A appear one times. The frequency of C appears two times and the D appear one time. Here is we have D here and E appear four times. E 1, 2, 3, 4 times. So we have to list all the items frequency. After listing all the items and its frequency, we have to find out the items which is greater than the minimum support 3. Consider our minimum support is 3. We already discussed in a priori algorithm about minimum support and minimum confidence. If the item frequency item patterns is greater than or equal to minimum support and confidence, we have to consider it for the pattern, frequency item pattern. Here also the same way we have to consider minimum support as 3, which means count is 3. Minimum support count is 3. So the items which is less than 3 must be removed and only the items which is greater than 3, the greater than 3 must be greater than or equal to 3 must be kept it in the database. We have to keep as a data item sets. We have to consider those item sets only. So here, if you take A, its frequency is 1 and it must be removed. And if you take B, it must be removed. And if you take C, it is 2 must be removed and D also must be removed. E, if you take E, 4 which is greater than 3 can be considered and 1, I is 1, K is 5, it will be considered. M, it will be considered. N, it must be removed. O, it will be considered. U, removed. Y is 3 which is equal to 3 so can be considered. So after that we have to list all the item sets. Here K appearing 5 times. So we have to list all this thing in order, that is E, K, M, O, Y. But if here after that that is E, K, E, K, M, O, Y. So here the value of E is 4, frequency count of E is 4, the frequency count of K is 5. So we have to arrange this in descending order. descending order, that is k is 5, e is 4, m is 3, o is 3, and y is 3. We have to arrange this list in descending order. Next, after arranging this list in descending order, again we have to make a table to find the ordered item sets. So the ordered item sets here E, K, E, M, O, Y. So consider the transaction T1 and we have the item sets which is already in the, we have the item sets. If we move to the previous one, we can know that is item sets are like E, K, M, N, O, Y. So out of this one, we removed N since it is less than 3. So we have already removed. So only those values, those item set present in the list must be considered. So here, out of this, we have E, K, E, M, O, Y because this has been removed in the remove. This has been removed. So we have to consider in the descending order. Likewise, if out of D, E, K, N, O, Y, after removal of the item which is less than minimum support 3, we consider E, K, E, O, Y in the order. Then out of these item sets, we consider E, K, E, M. Out of these item set, we consider K, M, Y. Out of these item sets, C, E, I, K, O, O, we consider only K, E, O. So these are the ordered item sets in descending order and which is greater than the minimum support 3. Next, we need to find a conditional pattern base. After finding the ordered item set, we have to find a conditional pattern base. In order to find the conditional pattern base, we have to make one tree structure, and from the tree only we can get this conditional pattern base. So we have already the pattern like K, E, M, O, Y. We arrange this in now ascending order because K is 5, E is 4. Likewise, we have already know. So now we have to order the item in ascending order Y, O, M, E, K. Now we have to construct like we have to construct the conditional pattern base from the tree. First, we have to take a root node as a null. Then we consider, for this we have to consider K. So already we have the ordered set like ordered item set in the previous slide. K, E, M, O, Y. I'll write again because we need this ordered set K, E, O, Y, K, E, M, then K, M, Y, K, E, Y. These are the ordered item set. Item set, we already found this one item set. So here to construct this tree, first we have to take, I told you, we have to arrange this in ascending order Y, O, M, E, K. So for to reach Y, we have the sets like to reach this Y, we have Y in 3 ordered set 1, 1, 2, 3. So we need to check these 3 ordered set. To reach Y, we have K, E, M, O. So we construct from null. We have to construct first K. Initially, need not to write this value. First, I remove this value. I remove this value. Then we can write all this value one by one while constructing this tree. First, the take first one K, E, M, O, Y. So write K as one node, E is another node, M is in another node, and K, O is in another node, and Y is in another node. So K appearing one time in the first set, one time, one time, one time, and Y is in one time. Next order set is KEOY. K out of KEOY, we have K already node we have. So we have to increase the value 1 by again because another K. So increase 1 by 2. So this is another K. Then E, increase it by 1. So we have 2. Then O. Here after E we have M. So there is no O direct path from E to M. So what we need to do, we have to construct one node, additional node of O. This is additional node of O from E to O, because KEOY, KE we have M, so don't consider this one. We have to construct one more branch here. So 0, I mean O appearing in one time, O, and here is already in one time, and Y is now in 1. Y is also 1, here is Y is also one time. The next is third set, because here there is no Y. So take the fourth set. Fourth set has KMY. So K, already we have K, increase it by 1, so 3 Ks. Now M, after K, directly M here, but after K we have only E directly. So we have to draw one more node, one more link, and then draw M, add it as 1 here. Now we have K, M and Y. Y is direct path, again we have to take one, draw one Y. Next, next pattern is we have to draw the next pattern is this is the one pattern. So this is the one pattern for Y, and next is for O. For O, we have O appear in three order set KEMOY, KEOY, and KEO. So this is one set, and this is one set for O, and this is another set for O, and this is another set for O. So KEMOY. So K is already there. So increase it by 4 by 1. So 4. And E, increase it by 1. It is 3. And M, increase it by 1. So it will become 2. And O. O is here. We have O here. So O is already present. So here this is the way to reach this O. Okay. The next one. Now we have KEOY. KEOY, we have K already exists, so increase it by 1, so 5. Then M already, not M, E. E is already there, so we have to increase it by 1, so it become 5. Then O. We don't have O after E directly, so we have to make one node and write this O. This is the O here. We have to make already O is already Y is 1. Now it will become 2. It will become 2 here. Now next one, K, KEO. KEO we have finished. So KEMO already done. Then KEO. KEO is we have done. It's a one time. One time is appearing. And now KEO. So KEO. One is KE. So next one is we have K. We have K. It's 5 already we have given, and E, it's incremented to 4. I mean incremented by 1, so it's now become 4. And O is directly we have to give, already it's 1, now it becomes 2. So this is how we have to find for each item. So now M means we have item set for KEM. So KEM already exists, so need not to write again. K here KEM already exists, so need not to find. Then KM. So KM, direct connection to KM is only one here. We have KM is already here, so no need not to write again. Then we have to find for E. E is E. Item set E. So item set E is Now KE, we have one more pattern. This is KE and KE, KE. Here is KE. In 4 item sets it appears E. So KE already there. Here also KE already present. KE is present. So need not to write it again with KE. There is no new node generated. So we have to keep as it is. Now the value becomes K equal to 5 times and E equal to 4 times and O equal to 2 times, then M equal to 2 times. So now we need to consider, now we have to take, we have to consider this one. So oh, we have to write the path, each path we need to write. So to reach Y, what are the path we have is KE from root to KEMO. This is one path. And another path is KEO. This is another path. And another path is KMY. So to reach Y, we have 3 paths. So this is the value we have to write it in each path. This is the output value. So this is the output value. We have to write it in each path. This is Y value. So what are the paths? KEMO, KEMO. This is one path. KEO is another path and KM is another path we have to write to reach Y. Next, to reach O, what are the path we are having is here, this is 1 and 2. There are 2 O present here. So here the output of Y is 1, output of Y is 2 here. This is the path KEM. So KEM 1, output is 1 here. This is colon 1 and KE KE, then directly O connected, it's 2. So we have written 2 here in the conditional pattern database, conditional pattern base. Now M. To reach M, we have 2 paths. One is KE, another is K alone. So to KE, what is output of M is 2. The path KE, the output of M is 2. So we have to mention here. And for K, the output of M is 1. So we need to mention here. Next one, E. So to reach E, we have only one path, that is K, and its output of K, E is 4. So K path, only one path K, and its output of E is 4. Output of E is 4, that must be mentioned here. This is the conditional pattern base. So to write a conditional pattern base, in order to reach each item, we have to construct a tree and find its path. Next, we move to conditional frequent pattern tree. So from conditional pattern base, we have to write conditional frequent pattern tree, which means the value for, the common value for from the common frequent item set, the common item set from each set. Here, out of KEMO, which is the common item present in each set. Here K is present, K is present, K is present. And here E is present, E is present, and here E is not present. So we have to write, and if we take M, M is present here, M is present in the third set but not in the second set. So the item must appear in all set. The common item must be, write it in the conditional frequent pattern. So K only appearing in all set we have written. So what is the output of this? Means 1 plus 1 plus 1 equal to 3. This is a 3 is a value. Adding, summing all the output of the Y, 1 plus 1 is 3. Now, if we consider the second O item and its conditional patterns KEM and KE, out of this, which are common items are KE and KE are common items. So its values 1 plus 2 is 3. So KE and values is 3. Now, if we take M item, what is the condition pattern basis? KE, K. So out of these two, K is a common term. So we have written K and 2 plus 1 is 3. Now E. E is the it has only one item, that is K equal to 4. So we have to write the set as it is. Now we go for the we have to write the frequency pattern generated. This is the final data. This is the final table for finding the frequent pattern generated. Out of this is a previous table. From the table, how we have drawn the frequency pattern. So now our item is a 4 the item is y, the y and from the conditional frequent pattern k to y, what is the value is 3, k to y alone, and we have to write the set k and y is 3. Now O has two set k and e, so ko one pattern and EO is another pattern because we have two item here K and E. So KO is one item one set and EO is another set. Then KEO is another set. So that is the value of this. Directly you write the value here 3 here in all sets, all patterns. Then M has only one K, so K and M alone the value is 3. Then E has only one K, so K and E is 3. So now finally K is null. So finally these are the frequent pattern generated by the FP growth. So these are the pattern for the entire transactions. Entire transaction. These are the patterns we generated from the FP tree, frequency pattern tree. Thank you.